Thank you, everybody, and thank you above all, Andrew Goodman. It's a pleasure to welcome Andrew back this evening. He last gave us a talk only months before COVID, in that other era, November 2019, on good modern architecture in Hertfordshire, approximately along those lines. Anyway, tonight the focus is on some more practical and even more pressing topics: staying warmer and helping save the planet, insulating our houses. Andrew's going to give us a presentation that I'm sure will be very helpful, and then there'll be plenty of time for discussion. And we have got at least some members of Hertford Against Climate Change here, people like Ray Bomber, as well as Civic Society members.
We're not against, well, we are against climate change, but it's Hertford and our changing climate.
Hertford and our changing climate. Thank you very much, Ray. And there might even be somebody from St Albans if we're lucky. Sustainable St Albans. Anyway, welcome to everybody, and above all, welcome to Andrew, and it's over to you now.
Okay, well, now I know one or two of you have definitely got your microphones on, so if you could all mute, that would be helpful. Great, and thank you for the invitation. So I've enjoyed preparing for this, so I hope I approximately address the topic tonight, both about staying warmer and helping save the planet, and the place of or the part that insulation plays in this. So I wanted to just start. This is a bit of a headline or a bit of yes, even the wider context before we focus in. In Glasgow recently, I think it's or last year, it was announced that this estate, which appears in the photograph, is going to be demolished with the idea to regenerate. Now, this has been happening quite a lot in Glasgow over the years, and I would have said Glasgow was quite a forward-looking council in terms of its policy on reducing energy use in buildings. Right, who's Dorothy? Someone's drawing on my screen. Can everyone see a drawing on their screen?
Yes.
Right. I think you need to undo what you've done, Dorothy, please. If not, I'll go on to the next slide because by way of contrast, in France, in this particular project in Bordeaux, the practice of Lacaton and Vassel, French architects who won last year's prize for architecture, have had this mantra of never demolish, never remove or replace, always add, transform and reuse. So I think one of the fundamental things always to remember when we are looking at improving the performance of our buildings, I'm going to use the term retrofit a lot as to describe how one goes about reducing its energy use for heating, hot water, and so on. But behind it all is that it's actually, it's much better for the planet to keep our buildings as far as possible because of the embodied carbon that's incorporated in those structures. So to demolish and rebuild using new materials and the energy consumed in making those materials is, to my mind, to be avoided. Another American architect this time put it this way: the greenest building is the one that already exists. And I think that's also quite a good kind of thing to work to. Now, hands up those who recognize this logo. I'll invite someone to unmute and just say, who do you think it is? No one?
Is it BRE? Oh.
No, so it's Insulate Britain, and I thought, yeah. Now we probably think of Insulate Britain as doing one thing. At least I didn't until quite recently, not appreciating that actually they produced this report in September last year, and had, in my view, quite a good summary of what one is aiming to do, what the need is in terms of retrofitting our homes. And it just very well summarizes the need to do it because of the climate emergency, because of the need to improve the living conditions in millions of the homes in the UK, the opportunity it would provide to increase employment, because we are lacking in the construction workforce to do this retrofitting works to our buildings, which in turn has a benefit to the wider economy. And it's even more prescient now, but they were talking about the question of energy security, and just acknowledging how we import at the moment a lot of our gas, albeit not as it happens from Russia, but still at risk, possibly of if the suppliers decided they weren't going to supply to us any longer. And they then run through the issue of how one goes about insulating, starting first with insulation first, or fabric first is another term that's quite commonly used, but also pointing out that one has to consider ventilation and damp issues, and the need to, which is in theory a sort of government policy to try and get us off using fossil fuels, gas in particular, for heating our buildings. It points out, and I would agree with this, that all the discussion about hydrogen is not particularly relevant or useful. And designing for new climates is about, actually, with the changing climate, we've also one of the things that we will be doing when we retrofit our homes is actually getting ready for a warmer climate and minimizing or reducing the risk of overheating. And also acknowledges that it can be a very messy process. So it does need to be planned. And then there's the question, lots of people will talk about how far do you go? I'm a member of the Passive House Trust as a Passive House designer as well as an architect. And they did a review last year and published it just a couple of months ago about the level to what goes for retrofit, and just related it sort of percentage reductions in use of energy in buildings, and spelling out what they call a shallow retrofit and a deep retrofit. And so these things are all come about when we actually look at insulating buildings. And it may or may not be I suppose, at the forefront of our minds when we're doing this, but yeah, the more one can do, given the targets that we're talking about, and the whole zero carbon target by 2050 or 2030, as some would submit is appropriate, or in 2025 if you go with Extinction Rebellion and Insulate Britain. These are all things that will come about when one looked at insulating your buildings. And so the trust kind of also related it to make some sort of assessment about how the existing housing stock perform, using the metric of what's called space heating demand. This is measure here kilowatt hours per square meter per annum. It's a way of comparing buildings' performance. So you can say like for like per square meter, this is the amount of energy used to provide space heating. And well, the biggest bar there is in the 130 kilowatt hours per square meter per annum range. It's a big speculation that typical new build is around about 85. And there are then on the left of this chart various standards that people have proposed: passive house new build, EnerFit is the passive house retrofit standard, and you can do that two ways: by space heating demand or using components performing at a certain standard. Then the ACB is an organisation called the Association of Environment Conscious Building, and LETI is the London Energy Transformation Initiative that have also looked into retrofit guidance. So all in the range for retrofit between 25 and 50 kilowatt hours per square meter per annum. And yeah, those are the kind of numbers. Now, and I think if at all possible, it is always useful to it's very useful to gain an understanding of actually how your existing building is performing in order to know how far you might be able to improve its performance. Now, I came across this cartoon just the other day on Twitter. So I apart from it being Clough and Innova and Partners, I have no idea who this is, where it come from. So I can't attribute it. But it's this thing about how we often go about missing the main point, which is what I'm talking about tonight. It is about heating. It's not, batteries won't get us out of our problem. Hydrogen won't get us out of our problem. DSC is a direct air capture, which I think is carbon capture, which is not really going to help us. We can't solar panel our way out of the problem. We can't electric vehicle our way out of the problem. And we've all the time, we've got these problems hanging over us about energy security and the actual climate goals and the changes happening to the climate and how we want to try and arrest that change in the climate. And another person, just briefly, is just sort of summarize it with this table here, this kind of infographic here about looking at, even if we had on the left, the column on the left is saying all our electricity comes from renewable sources. If we go the lower route of converting it into hydrogen and burning it in a boiler, that's overall efficiency of 62%. Whereas if we put it straight through the grid to heat pumps, then efficiencies average typically 300%. So for every kilowatt of electricity you use through your heat pump, you'll get 3 kilowatts of heat out, say. So that's kind of goes with the installation of properties, and is a kind of like a logical kind of consequence or follow-on from reducing our energy use through insulation. Now, this is a complicated table. I accept, but it was just is an attempt to just try and look at in the second column. So just the various materials that might get used to insulate a house. And there's no great sort of system to the order that they're in, apart from the fact that those top 2 or 3 PIR foam boards, or the brand names we are unfortunately very familiar with at the moment, if we've been following the Grenfell inquiry, Kingspan and Celotex. They are very commonly used in construction at the moment. The mineral wool or rock wool, our typical kind of loft insulation roll mats we're probably also very familiar with. Expanded polystyrene, extruded polystyrene. Again, you'll probably be able to get those quite easily through local builders merchants. Almost just go and pick them up, possibly. But from there on in, the wood fiber boards, cellulose, which can be new plant-based material or recycled newspaper material, sheep wool, and hemp, which is another plant fiber-based product. As we go on down, diathanite is a very interesting thick plaster coat that one applies as internal wall insulation. All this means we're going down to the bottom 15 vacuum insulated panels. which are very well performing, also extremely expensive. So there's not necessarily there is a sort of a ranking on sort of, I suppose, availability and cost as you go down that column. And with the color coding, I've just tried to sort of indicate a degree of warning when you're potentially thinking of using them, because you can definitely use foam boards which are vapor tight in certain situations where they could potentially harm your building. And I'll explain a little bit about how moisture works in buildings in a moment. And so with my sort of blank crosses, question marks, and ticks in the where the installations are used in different constructions, I'm just trying to flag up, you know, where one should be careful. And the manufacturers of these boards, for example, would say, well, you can use their products in suspended ground floors. You can use them as internal wall insulation, and you use them in timber constructions. And I would be very, very wary, very careful about doing that, because you can end up trapping moisture against timber and ultimately causing it to rot. The third column is this lambda value is a measure of each material's thermal performance, and so it's linear. So if we took this foam board in line 1 to start with, so 0.022, that means that if we compared it to diathanite at 0.045, you would need half the thickness of foam board to perform the same as the thickness of diathanite. So if you had 100 millimeters of diathanite, the same insulation level would be provided by 50 millimeters of a PIR board. So that's a factor, obviously, in considering which insulations you're going to choose. They perform differently. And it's not something that generally gets considered, I would say. And from these, when you know the lambda value, or this measure of conductivity, and you know the thickness of the product, you can calculate the resistance. And from there, the reciprocal of the resistance is what's known as a U value, which will kind of crop up once or twice here in later on in the presentation. And I can explain more about that if you're interested afterwards. I just don't have time to go into it in great detail. But the other thing about the color coding, just to finish on this slide, is yeah, the two red ones products are definitely totally fossil fuel. They're oil-based, petroleum-based products. So we might be wanting to think about not using so many of those in the future. Mineral wool glass, then the orange materials are also petroleum product based, but they're less harmful overall, I think, at least in terms of embodied energy, and in terms of what happens at the end of the life of a building. What happens to these plastic products, basically? Are they actually, a problem to dispose of or not? Going through to the yellow, which such as mineral wool, which are good products on the whole to use, to green being naturally based products, which are really nice to use, basically, if one can. And I'm going to show you I'm going to go through just 3 different constructions in a bit more detail. I can't go through all of these 15 odd columns here, or whatever I've got. No, 10, that's an exaggeration, but 4, 5, 6, 11 constructions. But I'm going to look at some examples of how to look at solid floors, suspended ground floors. I'm going to look at internal wall insulation on a solid wall, and a very common treatment that perhaps we've already done, but it still needs to be done, and that's loft insulation. So just going back then to the question of moisture, this fortunately has been produced by someone else back in, last decade, really. Yeah, nearly 10 years ago now. So you've got a little diagram about actually what is happening, both looking at older traditional buildings and slightly more modern constructions. But all of these, any sort of building has the risk potentially of moisture coming into the building through rising damp, through leaking roofs and gutters and downwater pipes. You can get wind-driven rain coming from the outside and going through the fabric. You've got indoor activities where the moisture generated inside might want to go back out through the fabric. Interstitial condensation is where moisture going in either direction hits a dew point and condenses within the construction. And I think in summertime, even there's this what's called solar-driven moisture, where actually there is a moisture gradient from outside to inside, in contrast to the more common winter heating season moisture gradient from inside to outside. And I did wonder about putting up this phrase from Dr. Paul Baker. He's based in Glasgow, I think, or the last I heard he was, but it's not rocket science, it's harder. That's could be a bit off-putting, but it just, to me, is another way of just saying we have to be careful and we have to think things through before we embark on this. But another architect friend of mine has summarized it like this about how he would approach retrofitting any building. The first one about get all asbestos out is he's learned from bitter experience himself, from his own experience. And there is this general advice, number 2, you carry out those repairs before you retrofit. So if you have got leaking roofs, if you have got some cracks in structure, whatever, you have to sort those out before you begin any sort of thermal upgrade of your building. Otherwise, you could be just accelerating potentially accelerating the deterioration of the fabric, whereas a well put together building, well insulated, will actually protect the structure. And the third point is to do as much as one can to understand how your house is performing before you start. A very, very simple way is just looking at your energy bills, and if you can, calculate your internal floor area, and you can work out and you convert your electricity is in kilowatt hours, but you want your gas use, if you use gas, also in kilowatt hours. And you can work out this kilowatt hours per square meter per annum figure. So it's quite a rough and ready way of working out where you're starting from. And then, as I've been saying already, do make a plan. And sometimes one can go about, and quite common, and it probably is a realistic way forward, but not everyone can kind of do the whole retrofit to the whole building in one go. So thinking about how one might do it in a step-by-step process, or phasing things, and for different houses and for different sort of perhaps family or occupant needs, there's no kind of set pattern. But what you don't want to do is to do something and then have to undo it later to do the next phase. So that's why one of the reasons you need to sort of be thinking that through in advance. And just one last slide, just at the starting point, these two graphs here. Again, the Passive House Trust just kind of wanted to try and check how the Passive House planning package tool, PHPP, which is to help designers build Passive House design buildings from scratch for their retrofit standard called Enerfit. That you can't model an typical existing building in it without adjusting it for how we tend to heat our buildings. I imagine most of us possibly have heating on perhaps for a spell in the morning and then of an evening. And a lot of people tend not to have it on in the day, tend not to have it on overnight. Whereas the whole premise of the low energy building, the Passive House, you actually just it is designed so that it is at a constant 20 degrees internally. But you need to make a sort of adjustment. So that the Passive House Trust just undertook this study, looked at it two ways. Both on the figure 3 on the left is sort of looking at how the PHPV prediction which was modified for this periodic heating compared to what we know about the national average space heating demand, and they then checked one specific dwelling in more detail with where the owners gave them their details of their electricity and gas consumption. And they kind of were comfortable with the fit, but it fitted when the average sort of typical internal temperature was around about 17 degrees rather than 20 in a new build passive house. So the PHPP is one way that one can model the buildings in much more detail beyond just what you might be able to glean from your utility bills, and can also help you then predict the difference that the different insulation strategies would make, and different levels of insulation would make that you might be thinking about. So there's another friend, Bob Pruitt, back just over 10 years ago, the part of the Retrofit for the Future program. He just happens to have got a nice summary diagram that I wanted to use. So in this house, it's a very typical Balham mid-terrace house. On the right here, at the frontage, which has been retained and tidied up and repointed, there's internal wall insulation. The floor section for the first half of the house is a suspended floor that's been insulated, but as is quite common with these back additions, it's got a solid floor at the back, so they needed to look at that. And then he has loft insulation at ceiling level in the front, under the front pitch roof, but in the shallower pitched rear roof, he's got insulation between rafters, where he's inserted a secondary layer there. And at the back, because it's out of the public view, they've used external wall insulation. And this will be a very typical kind of situation we might find ourselves in. There's not a single wall insulation, not necessarily a single floor insulation or a single roof insulation approach that might need to be applied to our houses, but several different approaches, various materials that are best suited for each of those approaches. The red line represents an air tightness layer, which is another aspect of retrofitting houses, which I don't have time to go into tonight, but does become part of the complete package when well insulated new buildings. And the same with thinking about ventilation. Again, I haven't got time to go into that tonight. So we're going to just look at, first of all, the first thing I'll look at is a suspended timber floor, options just for that. And this house here is it's in Scotland. I've just been following this guy on Twitter, so that's how I know what he's doing, and he's recording what he's doing himself to the existing suspended timber floor in this house. This elevation on the right here shows where he's ultimately aiming for, basically turning it from a 1.5 story dwelling into 2 stories. And if I was to say he was kind of a keen sort of outdoor sports person, that is actually the view from that window. He lives in Fort William, and that is Ben Nevis. And he posts some photographs every now and again where you just see grey murk, but that's a fantastic view. So I can understand why he's keen to live there and to improve this particular property. And so just working through these photos, I hope you can make this out. So the top left, you can see the existing timber floor joists, which look in pretty good condition, actually. But what he's been doing quite crudely is adding plywood to the sides to create a deeper void under which he lays this membrane here, and he's still allowing a ventilated airspace underneath this. But this is both to retain insulation and to protect it from moving air underneath, which reduces its effectiveness. So these three other photographs at the top just show it from slightly different angles how the membrane goes in. I mean, it all looks, it is time-consuming work. It is fiddly, but he's aiming here to create 280 millimeters, nearly 1 foot of insulation as his floor insulation. And because it's contained within timber materials, he's using a cellulose insulation here, it's just in a sort of its fluffy form that you can just place, literally just pour in from the bags. There's a bag there, and fill the cavity. A little bit of tamping, but not too much, before laying over this membrane that he's laying here is part of his air tightness strategy. It's an air barrier that will ultimately link with whatever he's going to do to his walls and around the rest of the envelope, including the new structure at first floor level. So this approach, yeah, he's thought carefully about how he's going to do it. He's doing it himself, so he's not necessarily counting his hours. It is labor intensive, but it's going to be part of, this element of his house is going to perform very well and contribute ultimately to him, he hopes, to achieve this Passive House EnerPHit standard. But what happens when you're faced with something like this, which is a project of mine a few years ago? The corner of the building here, you can see a brick plinth there. So you've got a thicker section of brickwork, and then conventional 9-inch brickwork, a solid brick wall there. And when you then go inside to look at the floor, this dates from about mid-1800s. It's not put together with such nice sort of regular timbers as we saw with that previous house. And in fact, everything is built off earth. Now, earth there is a lot of moisture coming into this cavity, I would say, from the earth alone, let alone any other reason. But there were air bricks. So the question would be, can one do a similar thing to what was done in that property in Scotland, or actually, given overall when you look at the actual potential risks, which is what I tried to sort of summarize with this, that dotted line there is approximately the existing earth floor. The wall starts like this, then it ledges with a timber there, which supports the ends of the joist. And the joists are very close to what could be a very damp section of brickwork, because the rain will come, or the water will come down the face of the existing render, sit on that plinth brick, and sit. Oh, thank you very much. We'll come inside there. There's no damp-proof course that one could see. Plaster could be damp. So what we decided, with the client agreement, what we actually did in this situation is to replace the timber floor with a solid floor. Now, in this particular project, the whole house was undergoing a retrofit combined with an extension as well. So all this work was able to be done. This disruptive work was able to be done in one go. And so what we've got is, we've got 190 millimeters of the PIR insulation. So that's equivalent to nearly 400 millimeters of your kind of loft roll type insulation. So that's a good level of insulation, a slab with a leveling screed and timber floor finish. And at the same time, in this particular project, and this is this Victorian building, we could not think about external wall insulation. So we were going for internal wall insulation, which I'll show you a little bit more detail in a minute, with the idea that the insulation line is as continuous as possible. There's a little point there which I'm not particularly happy about, but it's how it worked out. But we almost got the continuous layer of insulation, so we don't get what we minimize the risk of a cold bridge, whereby heat will leak from inside into the outside through a weak point. At the same time, we're thinking about in the blue line is a damp-proof membrane, and the red line here represents what we're doing in terms of air tightness. So we're thinking about air tightness as well. In this case, the existing plaster was taken off, and a lime-based plaster, or parge coat as we call it, put on the inside, which links with some tapes and membranes to the slab, which is airtight. That amount of concrete is airtight. So I got some photographs, both particularly now of the internal wall insulation in this project. So the three photos at the bottom are, the one on the left is the floor still there, the existing floor still there. We're beginning to start taking off the internal plaster. Here's the middle one, the floorboards are beginning to taken up and the timber floor removed, and back to the earth floor on that bottom right. And then the top three are upstairs. We've got the corner of the building. This is the room immediately above this, the ground floor room. So going through a similar sort of process. These are the existing replacement windows, which are also going to be changed on this project. And here we are actually, because it's a semi-detached property, we are looking at insulating the party wall, and yeah, making that also airtight as we go. And then the process of kind of putting it back together after having stripped the plaster off and removed the ceiling is this is the lime leveling coat having gone on here, still with at this point the original replacement windows. The ceiling is removed in this case in order to put in an air barrier on the ceiling and battens on the underside that's where cables will run for lighting and so on. And that membrane in the ceiling is taped to the lime parge coat on the inside of the walls to create the continuity of the air barrier. And here's our wood fibre insulation starting to go on from the corner. And when you come downstairs, obviously one's got to think about what happens where the intermediate floor, this is the first floor, meets the outside wall. And so you've got both joists coming into the wall, you've got also joists parallel to the wall. And what you're looking for is the continuity of the air barrier, the lime, and insulation in due course to go all the way through, so you don't get a cold bridge at this point. And here the joists, we've left them built into the wall because they're surrounded by brickwork laid in lime mortar and lime internal coat. There's going to a new lime external render going on. So we just taped up there because that could be a point of entry for air to bridge our air barrier. Just to finish off, by the time you come, these are all in the downstairs room. You can see this top right here, the wood fibre going on like it was upstairs. The fireplace we have left uninsulated, but it was coated with the lime finish plaster coat. And so these bottom two, the lime plaster going back onto the top of the wood fibre. So unfortunately, this is also the new flooring, but I obviously missed going to site when this was actually laid. So this is actually this finished screeded surface of the slab. I'm sure I was there when the insulation was going down and I saw that, but I just have not got the photographs to show you, unfortunately. And of course, like I think if we remember the diagram about with the way moisture comes, risk of moisture coming in the building through a wall from outside. On the left here, this is what we were starting with. This is the existing render on the corner of the building, and on removing it, this was a cement render that came off quite cleanly. It was not in good condition. We wanted to check the existing construction behind, and we did find a few little things that needed tidying up, repairing, like the lintel on that window there, and this crack here at this weak point in the brickwork, before putting a new lime render back on to kind of complete the retrofit or the renovation of that external wall. And then this is my last but one slide. Just the question of loft insulation. The amount of loft insulation, if one can get 300 to 400 millimeters, you are putting a good level of insulation into your property. But of course, most ceiling joists are maybe 100 millimeters deep, and so what ways can you kind of build up your layers of insulation? Well, in this example here there's a proprietary product to actually sit these legs on top of your existing, in this case it's a truss rafter, so that's one of those triangular legs standing up, and a rail that goes across, clips across the top, onto which you can put a chipboard sort of deck, so you've still got your loft storage, but you're not squashing your insulation. So I suppose what the example of this photograph on the top left here is, it's not perfect, but it's not. I've seen a lot worse in terms of how loft insulation is installed. The picture on the right, I sure must be. I can't believe it's a real photograph. I think it's Rockwell's sort of computer-generated image, I think, of the perfect way you can put a layer of insulation the same depth as whatever your ceiling joists are, and you then cross-lay layers of insulation subsequently. It is tricky to build them up without squashing it, but with this sort of kind of system on the left here, loft support system, you're giving yourself the best chance of getting a good depth of unconsolidated full insulation. And then the one thing that quite often gets overlooked on the right here is that there is always a risk of condensation on the underside of your roofing underlay. Some of them, a lot of them these days are actually vapor permeable. A lot of the older ones are not. And you've got cold air on this side of the insulation. Your warm room is below the ceiling. Whoops, I didn't mean to do that. And so to minimize the risk of this condensation forming, which can ultimately rot timbers if you don't address it, you want air to be able to get through at the eaves to the underside of the underlay. And there are various sort of ventilator products that you can push into the tight space of the eaves so that the insulation doesn't go up to the underside of the underlay and creates an air path. Now, if I would do that, even if you actually haven't got specific ventilation incorporated into your eaves. If we're building new build today, there are various ways to do that. In retrofitting terms, you can put ventilators in soffits to create an air path. But what you're looking for is air being able to kind of cross-ventilate from one side of the building to the other. If it doesn't get done, there's a risk, a moisture risk there, a potential damage in the medium term. But if it's a question of not insulating or not ventilating, I think I would still do a certain amount of insulation. If you record I should have pointed out, when I had that sort of big sort of matrix of materials and their situations in which they can get used. Going from top to bottom in the numbers is also related perhaps to ease of availability. The PIR boards and most sort of mineral wool installations, I did say, didn't I, that yeah, you can pick those up usually, they're usually available. The further you go down, the national builders merchants probably won't necessarily stock those, but they may be able to order them. But there are quite a lot of specific, what should we call them, ecological builders merchants out there. I've got some names there. So if one, if this is going to be made available either, well, as a PDF, Terry or Malcolm, these links will work if people want to sort of explore the websites. Otherwise, I could email them to you. They're not all like for like. Back to Earth. They started out as like clay plaster specialists, but supply wood fiber products. Ecological building systems supply the same things, and a lot of the membranes and air tightness products, as do Eco Merchant. Green Building Store does that, plus things like windows and mechanical ventilation systems with heat recovery. Lime Green, in the name, is Lime Focus, as is Mike Y. Passivhaus Store are a bit like Green Building Store, kind of a range of anything you might need for your really low energy retrofit. Passivhaus Systems they're probably the most local in terms of being in Essex, actually, but I don't know them, but a client of mine has come across them. And Timur, if I've pronounced that correctly, they're Welsh, also predominantly sort of lime-based type products. So that's me for now, but I'm very happy to try and answer questions.
Thank you so much, Andrew. You've taken us into a world that was certainly revelatory and interesting to me. New zones, new learning here. I don't know what everybody else thinks. One question that I wanted to ask is there a simple one or two things that people should be starting to do with, the typical house that's, say, 30, 40, 50, 60 years old? Would you say more insulation in the lofts and then some double glazing?
Yeah, I think most people would certainly advise the loft is an easy win. As I said, I've seen plenty of bad installations, so it would be worth checking whether you've got a continuous layer of the thickness that is appropriate, or even the thickness that is there at the moment. Quite often it does end up getting squashed and moved and not replaced. So it's that's the products you use there, whether it be mineral wool or some of the more natural materials, they're relatively easy to install. Mineral wools tend to be cheaper than sheep wool, and there's flexible wood fiber products for this purpose, but they tend to be a bit more expensive. So that is one. I mean, I could have gone into windows in terms of insulation, but again, I think that's probably another area. It's a question of kind of insulating includes windows and air tightness, really, to make the kind of the fabric perform as best as it can. And once you make your building airtight, you need to be thinking about ventilation, and really controlled ventilation, using it mechanically with low wattage fans in a ventilation unit become the sensible option. To do that, albeit you have got to then be thinking about how you incorporate ductwork within an existing building, which is not always straightforward. And then yeah, that's kind of the package in terms of fabric, I suppose.
Thank you.
I mean, the most looking at what I haven't covered is how you improve the performance of an existing solid floor. And so that can be well, any work to your ground floor can be disruptive. I think the two examples I gave you, you've got a feel for. The one in Scotland, the guy has moved out with his family into a mobile home while he's doing this. It's just impossible. Yeah, everything is stripped out at ground floor level in order to do that. If you've got a solid floor, sometimes you might conclude that you break it up and excavate a bit more and put back an insulated solid floor, for example. But that is very, very disruptive. When you're looking at wall insulation, one of the advantages of external wall insulation, which I didn't go into in detail today, is that it kind of protects the structure. The structure becomes onto the warm side, whereas if you put internal wall insulation, your kind of building structure is still cold. Plus, you've got probably cables for your power sockets and services running on the inside, so you have to redo those if you're doing internal wall insulation. So again, it's a level of disruption there.
Mm-hmm. Thank you. It would probably help if you were to stop sharing the screen so we can get everybody the chance to see everybody else and to ask any questions that they might have. Is there anybody who's got harboring a question and would they like to wave a hand or do something digital? Andrew's got a hand raised. Unmute, please, Andrew.
Andrew, thank you very much for your talk. Hertford is a town with many listed buildings. Would you like to comment on how you address insulation or improving insulation in listed buildings, particularly bearing in mind the restrictions imposed by, I guess, legislation?
Yeah, I think this is where the natural building materials come into play, particularly because if you're going to be allowed under any, let's say if it is a listed building, you're going to need listed building consent for anything that you might be doing, including internal wall insulation, because you could have some important features there that have to be retained or carefully removed and replaced. If say it's a brick building, for example, or even a timber building of a certain age and listed, chances are it will be lime-based products. So it will be probably breathing in terms of moisture movements might be working quite well, providing, say, render on the outside is in good condition and it's not got rain penetration, rain damage happening. So you want to use wood fiber or other natural materials for your insulation on the inside, just to not disrupt how that kind of process is actually working in the existing building. When it comes to windows, friends of mine have successfully got permission to use secondary double glazing. They've sort of refurbished and existing sash windows, single glaze sash windows, got them working well. Maybe you can do little improvements to make them more draft proof, but have fitted secondary double glazing, actually using evacuated glass, which is a very thin glass. It looks like it's single glazed again, but it has got a vacuum layer in the middle of it. So it increases it doesn't make it like a triple glazed window performance, but it makes it a very good double glazed window performance without, if you're very careful with your detailing design, without changing the external appearance of the building. So it's things like that which are commonly kind of moving forward. I would say my own experience, conservation officers that are advising on listed building consents and so on are still, none of you are conservation officers, are you? Still, perhaps not surprisingly, fairly concerned about changes and can argue that, well, listed building legislation is currently worded, I think, can say, no, we can just refuse any such changes because it's detrimental to the heritage asset, or deemed to be detrimental to the heritage asset. Whereas I would argue that, you know, I think if the Victorians had the double glazing or knew about double glazing, I'm sure they'd embrace it. You know, it's the kind of argument that doesn't wear well, but neither does the argument that, well, probably a building has evolved over time, so why can't we continue to evolve it, particularly in terms of making it fit for the climate emergency we have, and fit for the, you know, another 50, 60, maybe 100 years, which it might, if it's not retrofitted, improved, might not remain the case. So it's just if you wanted to put numbers against it, in the space heating demand kilowatt hours per square meter per annum, the AECB, the Association of Environment Conscious Buildings, say, well, if you actually if their standards saying we should be aiming for 50, if you get 100 with a listed building through, which is an improvement of its existing performance, do it. Because it will all help, and it will help preserve that building for a longer period of time.
Yes, I have sometimes wondered where on the spectrum of different councils East Herts Council comes in terms of being flexible around listed buildings.
Not very.
Is my suspicion.
Yeah. Yeah.
But
I can understand it. I think, I mean, if you take the example of photovoltaic panels that can be incorporated almost like, if you like, within the tiles or slates on the roof. Is that automatically detrimental to a heritage asset to install them? If it's not, when it's making a contribution to generating electricity in a renewable way, not burning fossil fuels. I mean, that's the very, very difficult one. But it's almost like the same with, if any of you have tried to get permission to install a roof window within a listed building property. That's not always straightforward. Again, visually, and this question of, again, as I say, it wasn't as if the Victorians didn't use a lot of glass in patent glazing, thinking of Crystal Palace and so on. It's not, they weren't against it. They just tended not to use it in the buildings. And neither the Georgians just had a very small roof windows, but if they were able to do it, make them bigger, they might have made them a little bit bigger, arguably. So to my mind, there is no weight given, I would say, in East Herts to an argument that's saying we want to do this alteration in order to reduce the energy used in the building to heat the building, and or to make it more comfortable, because it's less drafty and it's better insulated, which means that your internal surfaces are warmer, therefore you feel more comfortable. It doesn't carry any weight. A drafty building is good for you, it's healthy for you. Leaky windows, open fireplaces, let the air, 10, 20 air changes per hour is good. It doesn't have to be like that.
Right, I can see Barry's raised a hand.
If I might ask a question, Malcolm.
Do, yes.
Well, Andrew said quite a lot about moisture. And in my house, in the winter in particular, I get a moisture problem, and I use a dehumidifier. What does he think about that? I run it when the solar panels are generating electricity, so it doesn't actually cost me anything.
Right, okay.
Well, the problem.
Yeah. Well, it would be protecting your fabric long term. Because yeah, moisture ultimately will damage your fabric. I don't know how old is your house approximately?
1930.
1930. Yeah. Okay.
And
what wall construction does it have?
Walls, because it was before the legislation came in. They're not cavity.
No. It was right on the cusp. So I live in a 1931 house, which does have a cavity wall.
That's right. That's when the law changed.
Yeah. It makes a big difference.
It's a good idea.
Well, yes, it is a good idea, definitely. I mean, if you've actually, I don't know, does this stop? Would mold grow otherwise?
Yes.
Yeah. Mold is not healthy
in the winter, definitely.
Yeah. You must be pretty unfortunate, I would suggest. I don't know if you're in a particularly exposed location or whatever, but a lot of people get by without these problems. But even though in theory possibly you could say, well, no, the conditions are such that there should be more condensation. But
okay, thank you.
Anybody else with a question? Yes, Caroline Penn has raised a hand. You need to unmute, I'm afraid.
Yes, if you can't put the maximum insulation in your loft, are there other materials, presumably more expensive, other materials that are sustainable that you can use, which will be thinner?
So in what way couldn't you put in? What's limiting the amount of insulation in your loft?
If you've got a loft conversion or you've got storage in there.
Okay, yeah. Well, I suppose it would. I suppose basically we've got timber framing of some kind or another, whether it be ceiling, rafters, dormers, flat roof on a dormer or pitch roof on a dormer. The only way I would say is, I think I've not used aerogel products, and I know they are very expensive, but they come like as a roll mat. They were like second from bottom, I think, on my list of thinking that was the second most expensive product. But I would imagine you can theoretically, if you can get into a space, you could lay that over on top of whatever's there. But otherwise, one could with care look at insulation on the inside, which would reduce the size of your room, reduce your ceiling height, mess up with any electrics. But you would be able to incorporate an air barrier and reduce the heat loss through air penetrating the fabric.
So there isn't anything available at the moment that would be super insulating with a reduced thickness that's easily applicable.
Easily applicable, yeah. You see, even the PIR boards, which are efficient for their thickness, if you put them as an internal layer on timber framing, you'd have to I think really make sure that you've got a decent vapor control layer on the inside. So you just don't want any moisture going into that, even though it's a fairly vapor type product in its own right. But you just don't want anything going in. And then you've got to hope that anything that's come in from the outside can get back out in some way, rather than getting kind of trapped at that point between the timber construction and your vapor tight insulation layer on the inside. It would be risky.
Yes. Thank you. Yes.
And most builders would do it though, because they wouldn't know about that.
Thanks.
Andrew again.
Andrew, just following up that last question, there is a material which is used, I know from experience, for insulating conservatory roofs. It's actually a material that was used by NASA to insulate their spacecraft. I don't think they use it now, but
right.
It is very thin. It's actually made up of 19 layers of material. How it works, I don't understand. But of course, what you've got to do is you've got to make sure there's ventilation above it, that it's not going to form a vapor trap.
Yeah, I think what it was marketed as 20, maybe 15 years ago, up to maybe 10 years ago. To me, it never made sense in terms of physics. Maybe it only works in space because space is a vacuum. So as you say, you needed to have a battened layer on the, I think both sides actually. You need a kind of, but on the outside face, yes, that was to have a ventilated airspace. And then, and you got this very thin material that gets pinched when you fix through from your linings on the inside, or batten and lining on the inside, to virtually nothing, and then the insulation probably that material is not continuous, the joints aren't taped, it's continuous. So the air moving in the outer ventilated space probably just comes whistles straight through to the inside. So I just couldn't see how it would work. So whereas when you're thinking about thermal conductivity of materials, that lambda value that I was talking about, and relating to the thickness of the product, you then get a measure of the heat that gets that gets transferred from the warm side to the cold side, and you can build up that. Hence, you can then properly calculate the U value of the overall construction, where it be it a wall or a roof, and calculate your overall heat loss from the building. I don't know how you wouldn't be able to do that with that material, I'm afraid.
Thank you for the very interesting suggestion there, Andrew. We're more or less running out of time now. If anyone had a last burning question, there's probably just time, or a brief query. Otherwise, it remains for me to say thank you so much for taking us into this very complicated and important world, and making us aware of the issues, which are a little more complicated than I was aware of. But we have to sort of keep on exploring, and probably we need a bit of expert help from someone like Andrew Goodman to take us there.
I could probably just extend. We see some of those suppliers, the merchants I had at the end of the list. They are very helpful for you to sort of say, this is what I've got. What do you recommend? They would do well. They have products to sell, but I think I've heard a lot of them speak, and I have no doubt about their knowledge. They know what they're talking about. I would say they know what the issues are, and so they can be, I think, helpful. There might be one or two other. It is tricky to point to the any particular single source of good, clear advice. So what I didn't go into, but I would just mention now is that through the government has been developing a retrofit strategy. There's a British standard, I think certainly exists in draft form. It may even have been published, but kind of is trying to set out a process that makes sure that some of the pitfalls that can happen don't happen. And one of the key, they kind of developed what they're calling a retrofit coordinator as a new key role, to sort of someone with the appropriate expertise to guide people through the whole process. And until such time that maybe a builder would actually know, and that oh, this is what we need to do. This is good from the point of view of building physics. This is a good approach to take, and will reduce your energy use, because the insulation and other measures are properly fitted. But that's not quite out there yet either. But it's coming. It's definitely coming.
So we need to keep watching this space, you're saying?
Yeah.
Well, thank you very much, as I say, for giving us a bit more hope that things will get a little bit clearer still. And that's very
I thought someone would ask me about the Chancellor's statement today in terms of knocking some VAT off. Well, he's a bit unclear as to whether it's just purchasing certain materials like insulations and PV panels, or whether it includes their fitting. There's been a campaign for years to actually have zero VAT on any building refurbishment and repair, not just listed buildings, but anything, because it makes sense to maintain our buildings in terms of the overall carbon equation, and put VAT on the construction of new buildings, which of course it's the other way around at the moment. Bizarrely. So there's no
bizarrely indeed, yes.
Yeah.
Well, anyway, many thanks.
Well, thank you.
Goodman. Caroline Penn has a last quick question.
Can I just say, it's not a question, it's just I've put in the chat some links to Sustainable St Albans, who I'm volunteer for them, on the sort of cheap and cheerful energy saving methods, and also a blog on retrofitting a Victorian end of terrace house, and also you can find out about the thermal imaging camera program there too. But thanks very much for a really interesting talk. That's most informative.
Yes, thank you very